Okay, so what we're going to do here is we're going to derive the resistors in parallel formula. Now, if this comes up in the exam, you will be given this diagram or something similar. And often it is phrased in a way that you suggest you have to use the conservation of charge as your start point. And that's what we're going to do here. Now, we're just going to quickly add to our diagram a few points. We're going to add here that this is the total current, this is the current through 1, this is the current through resistor 2, and this is the current through resistor 3. We could also say that this is the EMF of the cell, or the energy per unit charge of the cell. Now we're starting from a point where charge is conserved, so let's write that as the start of our derivation. The first thing I'm going to write is charge is conserved. So what does this mean in terms of this circuit here? Well, what it means is the charge that's flowing through the cell that's coming through here will split at the junction but won't disappear. So in this case, some of the charge will flow this way and some of the charge will flow this way, but it doesn't disappear. And when we get to these, the other side of the junctions, they're going to meet back up and will be the total charge again. So what that means is we can say the charge per second here, which we'll write in green, the charge per second here is going to equal the charge per second here plus the charge per second here plus the charge per second here. Okay. Now you might have already spotted that the charge per second we call the current, and that's what we have labelled on our diagram here. So we're just going to write to the side that I is equal to Q over T, the charge per second, and we're going to substitute that into our formula here. So we end up with the total current is equal to the current at 1 plus the current at 2 plus the current at 3. Okay, now what we're going to do is we're going to substitute in another formula that we have for current, and the formula is V equals IR, also known as Ohm's law. We're going to rearrange so that I equals V over R, and then we're going to substitute into each of these terms here. So we're going to end up with V total over R total is equal to V1 over R1 plus V2 over R2 plus V3 over R3. Now the total voltage we're talking about here is the EMF, okay? So we could have written the EMF here. Now in a circuit like this, which is a parallel circuit, you should know that the EMF of the cell is the same as the voltage across each branch of our parallel circuit. So that means that our total voltage, or our EMF, is equal to V1, which is also equal to V2, which is also equal to V3. Now the nice thing about this is that means all of our voltages can cancel out of this formula, and that leaves us with 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3, which is our resistors in parallel formula. Now you need to practice writing this for the exam. This can be worth, 3 marks, and really it's just a memory exercise. You just have to practice writing it out as many times as possible. Make sure you've got all these points in here, and you will be fine. Okay, see you in the next video.